Hello, welcome back to our YouTube channel. Today we are going to see Leetcode Biweekly Contest 143 and problem is 3346 and 3347. So both questions are same, only constraints are bit change. So there is no such impact like we can use the same solution for both, right? So what is the problem here? So we are given like the problem name is maximum frequency of an element after performing operations. Okay, the problem type is 1 and 2, two questions. So let's see what is given inside this problem. So we are given an integer array nums and two integers k and num operations. Okay, so we must need to perform an operation num operation times on nums, where in each operation you select an index I that was not selected in any previous operations. So what does this mean? You can select a unique element every time, right? And then what you need to do, you need to add an integer in the range of minus k to k, two nums of I. Let's say your nums of I, this nums of I is 5, let's say 5, and you have k equal to 3. Now you can add minus 3, minus 2, minus 1, 0, 1, 2, 3, anything to this number. So this number can be converted to 2 when you add minus 3. When you add minus 2, it will be minus 3. When you add this, it will be 4, then it will be 5, then 6, 7, 8. So this is the range possible, like you can get all this range by this number only. Okay, this is given. So what we need to do, we need to return the maximum possible frequency of any element in nums after performing the operations. Like after performing all the operations, what is the number we can achieve? Like if we do all things optimally and in the best possible manner, what is the number, what is the maximum frequency we can achieve? Okay, and what is the frequency of an element is the number of times it occurs in the array. It's a simple thing. Okay, so let's see an example to understand it better. Okay, so in this case, first we have this example 1 4 5, k equal to 1, number of operations we can perform are 2. So 1 4 2, what is the one possibility? Like number of operations are 2, we can either choose this number and this number, this number or this number, or this number and this number. This is the possibility, right? So what we need to do here, so let's say if we want to modify this element, what will happen? It can either be 0, because we can do k minus 1, we can add now 1 minus k, so it will be 0. Or it can be like we don't want to add we want to add 0, 0 is in the range, so it will be 1 again, and what it can be 2, right? This is the possibility. Now if we take this number, can we achieve any of these number? No. What the least from this number we can get? 3. What is the max we can get? 5. Perfect. From this number, what is the least we can get? 4. What is the max we can get? 5. 6, sorry. Now see the range. Here the range is 0 to 1, right? Now what is our goal? We want to make the number same, right? We want to make the number same. But if something is not overlapping after taking care of all the possible combinations, that means it is not possible. It is not possible, right? So let's say in this scenario, what is the range? 0 to 1, right? Now go further. We have 3 and 5, we have 4 and 6. Now this range is du like overlapping this particular range. This particular range is overlapping this particular range. That means we have something common. We can achieve something. Like 4 and 5 numbers are common. 4 and 5 numbers are common. That means either we can achieve 4 or 5. These are the two numbers. Like the maximum frequency will be 2. And this is the possibility. Right? And who will contribute? This number and this number. So we will not perform anything here. We will directly perform here. Like it is not able to contribute anything. It is not overlapping with anyone. And these two are overlapping. Now we can take. So let's say what can we do? With 4, either we can add 0, -1 or 1. Let's say we are not adding anything. Keep it 4 only. Okay. So add 0, that means it is 4 only. In the next number, now we can choose this number 5. And 5, what we can do? We can either add -1 or 0 or 1. Now let's say we are adding -1. If we add -1, that means 5 will become 4. So now your elements are 1, 4, 4. So what is the max frequency possible here? It is 2. And that is your answer. Perfect. Now let's see another case. What is the another possibility? Now instead of adding 0 here, what we can do? We can add one element. So if we add one element, that will become 5. And instead of reducing 5 by 1, we can keep it same. So it will be 5. So this is also one possibility. So what is the answer possible here? It is 2, the same answer. Right? Now, like how can we approach this problem? Now you understood, like you guys understood what is the problem. Now we need to think about the solution. How can we think about the solution? So what is the hint inside this question? Hint is this. This is the hint. -k and k. How? That means this is the range question. And in range question, there is one concept called difference array. Difference array. This is the range. And what is this algorithm called? This is line swap. We want to sweep from starting to end to achieve something, to know what is possible in this range. Make sense? Okay. So now we will try to solve this problem with this approach. Okay. So let's see what can we do here. Problem is very clear now. Now just we need to find the solution. So now let's say we are making a range. So what is the range, maximum range? It is possible that what is the number, max number, that is 5. And what is the, like what we can add? K we can add, that means k. 5 plus k, that is, this k is 1, so this is 6. 6 is the range possible, right? So let's try to make some okay, let me draw. Now we'll make the array. Okay, now we have 0, 1, 2, 3, 4, 5, 6, 7 and 8. Okay, we need till 6 only, but I have added, so that is extra, no worries. So now what can we do? There is an element called 1. Where it can go? It can go least till 0. Least till least till 0, and the max it can go to 2, right? So we need to cover this. We need to cover this range, and here the impact of this range will be reduced. So what we will do? Initial everything is 0. Now we will add 1 here and remove it from here. At this point we will remove. Okay, so we'll add -1. Now 4 is there. Where we can go least? Least is here only. 4 minus 1, that is 3. 4 plus 1, that is 5. So we need to cover this range, this whole range. Now we will add 1, then it will again become 0. And where we need to reduce? Here, because this is the range it needs to cover. So we will do -1. Now 5 is there. What is the range? 4 to 6. 4 to 6. We will add 1 here and reduce here. Okay, now this is the array. We will go from here to see the impact, like can we achieve something, right? Or, and one more thing, we will always take care of the frequency of the element. Okay, frequency of the element is very important. Why? Because in this range we are having these numbers, but what is the possible, like if it is available already, if something is available already, right? Okay, so this current, like we will start from here and go. So let's say we are at this point. What we will add? Current will be 1. At this point current will be 1. Now what is our goal? We need to check if it is maximum, like if it is achievable. If it is achievable, yes, why not? Current 1 is achievable, right? We can make, like this is the one frequency we have. But at this point, what is the frequency? What is the frequency of 1/0th element? Is there any element present here? No, it is not present. So 0 can be achieved only one time. The frequency is possible is only 1. Now come to this point. It is 0. All these values are 0. All these values are 0. So now nothing will be added. But till that current is 1. Current is 1. But what is the frequency possible here? Frequency possible is 1, because 1 is there in the array, right? 1 is there. So 1 plus 2. Like the maximum we can get 1 frequency plus 2, the number of operations we can do to make it happen. But what it is saying? It is saying current can be achieved only with this. Only one number is possible till here. We can't have any other number. So it's not possible. We will not have this. Okay. So till here answer is still 1. Answer is still 1. We are not able to achieve anything till now. Now come further, like come at 2. Is it possible? No. 3, no. 4. Now you come at this point. Now current will be 2. Now you need to take 2 plus, what is the frequency? Frequency of 4 is 1 plus 2. This is the what? This is what we can achieve maximum. If this reaches some like extra, like let's say it reaches 5 or 10, because everything is overlapping, but number of operations are very limited, then this will come into the picture. Okay, so here 2 is possible, we can have it in our answer and then add again. It will be same, like I explained you earlier that what are the numbers possible, 4 and 5, and at the same point we are getting value 2, 4 and add 5, because 2 will be there because nothing is removed, it is adding 0, so answer will be 2 only, but the possible candidates are 4 and 5. Now come at this point 6, this will be reduced, this will be minus 1. Now you are not able to achieve anything. Same with this, it will become 0 now. Now you can't achieve anything, right? So this is the possible thing. So how can we solve this problem? This is the solution, right? So we can achieve the solution with this. We got it. Now let's see the code to understand it better. Okay. So what are the things we need? As we know, the numbers are very large, right? Numbers are very large. So what we will do, we'll need a frequency and differences map. Instead of like taking a vector, we will utilize map. Why map? Because whatever is coming, we will use only that much space, nothing extra. In vector, if some ranges is there, so what is the maximum range possible? It is 10 raised 9 plus 10 raised 9. This is the maximum possible range given in our question. So if we define static things, this range will be there. So this will lead to TLE. This will lead to MLE. We can't afford that. So that's why we will use maps. Maps are like using that much space, whatever is required. No extra space. Okay. So this is the reason. Okay. Now what we'll do, and I am also keeping a set. Okay. Set I am keeping one thing. So now what we are doing? We are creating the range, right? By going every number minus k plus k. So minimum will be the I minus k, maximum will be the, there is a point we want to reduce, right? I plus k plus 1. Okay. Now if this minimum element is less than 0, that means like something coming here. If there is a number called 5, let's say all numbers are positive in our current given nums. So if number is 5, so something is going negative, let's say minus 10, but it is also going to 15 as well. If it is going 15, that means this range, whole range will be covered and everything will be accumulated at 0. So that's why we are accumulating everything 0. Like if there is anything less than 0, we will mark it as 0, so that everything will be accumulated. Why would we like to go in the negative direction? There is no sense. Okay. That's it. Okay. Now what we need to do? We need to increase the frequency and decrease the frequency of maximum elements. Same what we are doing here. Right? This thing. Like we added here, subtracted here. The same thing we are doing. And we need to increase the frequency as well. Okay. Frequency we have increased. Now I am storing all these three variables in my set. So what this set means? This set means we want to, like, these are the possible candidates of our answer. Whatever is there in the set, these are the possible candidates for our answer. Okay. So let's go further. Now we'll take the max frequency, calculate the max frequency. It is easy. Okay. Okay, so now we calculated everything. Now we just need to calculate our answer. So what we need? We need one answer variable, one current sum. This is a running sum. We'll calculate from this difference array. This difference array. From this we will calculate the current. Okay. So what is the current, like what is the value of it? Difference of I, because we have added here, right? So we have added that thing. Now we need to calculate our answer. What is the, like, we want to have our answer maximum answer, so we'll need to take the maximum, but we also need to take care of this num operations. We can perform limited number of operations now. Like, let's say numbers are 1 1 1 5 1 1 1 only, let's say, and you have k equal to 10, right? These things are possible. Like, we can have 0 0 0. At 0 we have lot of frequencies, but number of operations are allowed only one. We can modify only one element, but we want to keep everything. In current we are keeping everything, but here we are reducing. Like, this is the maximum possible, we can't go further. So we'll take the answer as maximum of answer and minimum of current comma frequency plus number of operations. Like, this number is present this much times, and what is the frequency? What is the, like, if current number is available 5 times already, and now we have 3 operations more, right? 3 operations more we can do. So the maximum what we can achieve is 8. Whatever is there in the current doesn't matter. Okay, now we got this. Now at the end we need to return the minimum of answer comma max frequency plus number of operations. Okay, so let's say by this we got something. Now we need to take care of this thing as well. Like, what is the max frequency? Okay, and take the minimum of it, this range. So this is very straightforward, right? So what is the time complexity of this solution? Okay, so what is the time complexity? We are performing everything in the nums array, so O of n for sure. O of n, let's keep it O of n. So let's fill it. Okay, so let's keep it O of n. Okay, now what we are doing? We are also inserting elements, and this is the sorted set. So what is the insertion time? Log of n, so n log n. Perfect. This is the time in this loop. Now we need to use those elements, right? So how many max elements are possible? 3n max elements. Like, we are inserting mini, maxi. Let's say if all elements are different, 3n elements will be there. So the time complexity will be O of n log n only. What is the space complexity? So now we are using 2 arrays. frequency difference, okay, and set as well. So 3n is the space. This is the space complexity we are using. Okay, so if you understood this problem, do subscribe the channel, like this video, share this video with your friends who wants to understand the solution. Okay, keep coding, keep watching. Bye bye.